Alright, so today's topics, it's called kinetics of particles, but the method is impulse and momentum. So we're going to be solving almost similar problems, but doing with another method. Okay, so let's take a look at some examples. For example, of impulse. So let's say this is looking at an automotive fender. So let's say you've got a dent in this fender. So in order to remove this dent, you need to hit it with a hammer, or you can use something called an impulse tool. So what it does is that you can give it an impact to this surface, and when this thing goes up, it's gonna hit it, and from your dent fender, you are giving it a force, and you're trying to make it back to its original shape. So in order to move something like this, you would be able to do it by gradually pressing on it, but then it would take a lot of effort. So one of the best ways is use something called impulse. So when you are using your hammer, you are basically creating an impulse. So impulse is something to do with time. You are giving a certain amount of force at a very short period of time. So things like that. So next, for example, if you are hitting some sort of a head sledgehammer, so you are creating a large impulse force to the ground. So you're trying to break the concrete or cement on the ground. So this is also an impulse condition. So you need to know a few things lah. Initial speed of the sledgehammer and the duration of the impact, and how do we determine the magnitude of the impulse force delivered to this rod or stick. So this impact comes from the principles of linear impulse and momentum. So where do this come from? It comes from your Newton's second law, coming from F is equal to ma. So A, you replace it with this one. A is equal to dv over dt from this equation. So when you bring it there, let's bring it there. So F is equal to m dv over dt. So dt, you can bring it over here. You're going to get yourself F dt is equal to m dv. So now you can integrate this part. You're going to integrate it over time. For this part, you're going to integrate it over velocity. So you've got t naught until t, v naught until v. So when you integrate f dt, you're going to get f t. Or t minus t naught lah. This one you're going to get mv minus v naught. So f t minus, if t naught is 0, that's just it. So you're going to get mv minus mv naught. So okay, this one is done actually. Yeah, something like that. So these two things, this F times T is called impulse. So what is the unit for impulse? Newton second. So this is the unit for impulse. This is something called momentum. M times V is momentum. So now you have something called change in momentum. So by using this formula, which is this one, f dt mv2 minus mv1, you can solve a lot of problems by using the principles of impulse and momentum. Again, so let's look at some examples. What do we have here? This is heavy, 12 megagram. So this jet weighs 12,000 kilogram. This is a jump jet. So it's capable of taking off vertically from the ship. So it exerts a constant vertical force of 150 kilonewton on the plane. So determine its velocity and how high does it go in time is equal to 6 seconds starting from rest. Neglect the loss of fuel. Okay, so M is M is constant. So there you go. What to do? You need to find velocity in t is equal to 6 seconds. How to do this? If you are solving it using summation of force is equal to m, if you're using the previous method, which is Newton's second law, summation of force is equal to ma, can you solve something like this? I bet you do. You can get the acceleration, and then you can even get what is the velocity using kinematics equation. You can do that. It would be very easy. But let's try out another method lah, which is this one, which is this formula f integrate f dt is equal to mv minus mv naught. Summation. This is the new formula that we want to test out. It's basically coming from the same thing. Okay, let's try. Number one, definitely we need to draw a proper free body diagram. So this is a 150 kilonewton going up. You have mass mg going down. Is there anything else? Is there anything else? I don't think so. 150 kilonewton at atas. So it's traveling upwards, so upward is positive. Acceleration is going upwards lah. So 100 f dt, ft lah. So integrating f dt, you're gonna get ft. So let's write down the formula. 150, since it's a kilonewton, so 10 to the power of 3 minus mg. So you're gonna have dt here. You're gonna need to integrate from 0 until 6 seconds. mv minus mv naught. So original velocity, is it at rest? Jump jet is taking off vertically from the deck of ship, starting from rest. So if it says here starting from rest, then you know already v naught is equal to 0. So this part is done. So only thing you get to integrate this one. 150 10 to the power of 3. Okay, let's do that. 150 1000 t minus mg 12,000 kali 9.81 t lah juga. Why? Because when you integrate f dt dapat ft. Okay, so there's a t value there. What else? Summation, you've done it. You've minus mg minus t. So, no, yeah, correct lah. No, it's actually 150 minus mg. This is the summation. So, what to do now? This is the value that you get. So, this is the limit from 0 until 6. Mass berapa? 12,000. Velocity, you don't know. Yeah, typically when you're doing anything, make sure you have one unknown lah. This is the thing that you don't know. Otherwise, your equation is useless lah. Okay, so this one becomes 150 kali dengan 6. Tolak. Ini jadi berapa? 12,000 kali 9.81. 117720 kali dengan 6 sama dengan 12,000 V. Yeah, I don't have to put the thing never mind lah. So if you want to simplify we can really simplify it. This one I don't have to put 1,000 here. This one becomes a decimal there. This one also gone. So because of this value lah, it's like you divide by 1,000. So now it becomes 150 times 6 lah. Kali 6. 900 minus 117.72 kali 6. 706.32 06.32 bahagi 12. Dapatlah V berapa 900 minus 706.32 bahagi 12. Sikit je. 16.14 meter per second. Is this correct? Do I have the answer? 16.14. Okay, betul. Betul itulah, betul velocity. So velocity is correct lah. Velocity is correct. So next. How high does it go in time is equal to 6 seconds. So you can use this or you can either use kinematics equation. Let's try out some kinematics equation. So one thing for sure, you need to identify you need to ask you a few questions. Number 1, ask. Ask who? Ask yourself. So you need to ask something called, is the acceleration constant? Is it constant or not? So these are the things that you really need to ask. Is it constant or not constant? So in order to judge whether the acceleration is constant or not, you can ask yourself these things. F is equal to ma. Is the force constant? 150 kilonewton. Betul lah, it's constant lah. F is equal to 150. F is not equal to 150 t squared. If F is equal to 150 t squared, dia bergantung dengan time. You have this time domain here. So every seconds the force changes, but that's not the case, right? So this is different. So F is constant. So is F constant? What is how about M? M ni constant tak? So it says here, neglect fuel lost. So this one is also constant lah. Because why? You neglect fuel lost. So A is confirmed constant. Is the acceleration constant? You answer yourself lah. Yes. Yes. Okay. So if the acceleration constant, you can use the three formula that we have learned. Equation number 1, V is equal to V naught plus AT. Equation number 2, S is equal to S naught, blah, 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 blah. Very long one. Third one, V squared is equal to V naught squared plus 2AS. Which formula is very easy? Dia suruh cari apa? S. I think use the third formula lah. V squared minus V naught squared divided by acceleration tak ada pula. You don't have acceleration. You gotta use the second formula lah then. This formula no good. This formula so useless kot. Useless. You gotta use this second formula. S is equal to S naught plus V naught T plus half AT squared. Acceleration berapa pula? Doesn't give you acceleration. Cari je lah kan. Susah betul. Cari je lah. Tak payah guna ni lah. You can find out from this one. V sekarang 16.14. Originally 0 plus A. Time sekarang 6. A sama dengan what is this? A sama dengan 16.14 bagi 6. 2.69 lah. A is equal to 2.69 meter per second squared. Use the third formula again. V squared is equal to V naught squared plus 2A S minus S naught. So final velocity berapa? Yeah, you got it. 16.14 squared. Original velocity 0 squared. 2 kali 2.69 S. S tak tahu. S not 0 lah. Originally at rest. So if you settle this one, you're gonna get it lah. 16.14 squared divide by 2 divide by 2.69. 48.42. S sama dengan 48.42 meter. Betul ke tak? 48.4 betul. Okay, do it yourself. Kind of complicated a bit. You could have solved this easily using F is equal to MA. So depends on you lah. Something like this you cannot use already. You cannot use F is equal to MA already. This one. Actually can also lah. Just integrate lah. Yeah. Okay. 28 megagram bulldozer is originally at rest. Determine the speed when time is equal to 4 seconds. Time is equal to 4 seconds. Sini 10, sini 5, 4 kat sini kot. Force lebih kurang je, 3 something lah. Determine speed when time is equal to 4 seconds. So what to do? F is equal to MA. You are doing the same thing. F is equal to M dV over dt. dt bring over here. F dt is equal to m dv. Integrate both sides. You are solving it using F is equal to ma also. In fact, the whole dynamics book is based on this Newton's second law, laws of motion. Okay, so let's solve it. F is equal to that one. So F pergi ke kanan, it goes to the right. Any friction kinetic, any resistance, nothing. No, so just plug in this one. 4 minus 0.01 t squared dt. Integrate from 0 until 4. So ini dia tengah cari from this one, right? Okay. He is trying to find from 0 until 4. I'm trying to get this one. So that's why I do integration from 0 until 4 dt. If later on I want you guys to find this one, let's say from 10 second until 15 second. So what you do is integrate from 10 until 15 dt. So this is what limits is all about. You are analyzing at the location of your interest. Currently, this one 0 until 4. Currently 0 until 4. This one is equal to mv minus m v naught. So what do you do? Integrate lah. 4t minus 0.01 t kuasa 3 per 3. Evaluate them from 0 until 4 sama dengan mass 28 megagram. So 28 10 kuasa 3. Velocity you don't know. Originally at rest. So this one is gone. This one is 0. So this one becomes 0 lah. This one is 0. Okay, what else? Yeah, pretty much lah. That's it lah. So 4 times 4 minus 4 cube. Yeah, one thing for sure that I've forgotten is this one. This is kilonewton, so you have to be careful lah. This is 10 to the power of 3 already. So meaning all these things 10 to the power of 3. Okay. This one 10 to the power of 3. So I don't need to put this one anymore lah. This one cancels out lah. This one cancels out. This one cancels out. Okay, so this one becomes 28V only. Okay kah? I think so. Alright, let's try. This one is 16 minus 64 times 0.01 bahagi 3. Very small amount. 0.213 divided by 28 equals V. V sama dengan 16 minus 0.213 bahagi 28. Velocity is 0.01 0.56 meter per second. That is the velocity. Okay. Alright, and you can look at the answer lah, it's correct. So this is how you do it lah. What is tricky? Is there anything tricky here? Nothing lah kot. Integration lah. The tricky thing here is integration. We don't do integration every single day, so do you remember? So whenever you need to do integration, you gotta freshen up on your knowledge on integration. Okay, next. We're gonna pause. Okay, so this is the next exercise on momentum. So you've got a 15 megagram boxcar. 15 megagram, it is how much? 15 ton. Coasting at 1.5 meter per second. Dia gerak macam tu. And tank B 0.75. 12 megagram. 12 ton to the left at 0.75. If the car collide and couple together, determine the speed of both cars just after coupling. Average force between them if the coupling takes place in 0.8 second. This is time. Okay, so something like this. You are going to use principles of conservation of momentum. So you've got two cars, right? This has a mass m1. This has a mass m2. m1 is traveling to the right at v1. m2 is traveling to the left at v2. So each of them individually is observing the principles of impulse and momentum. So each side, Ft is equal to mv minus mv naught. Each side. This one also same, Ft is equal to mv minus mv naught. So if both of them collided, crashes with each other, the crash takes time 0.8 second. So time is something that they share. Time is something that they share. F is also something that they share also. F is you have a force to the left, you have a similar reaction force to the right hand side. So Ft is equal to Ft. So in both equations, so in both equations, the previous momentum is going to be equal to the final momentum. How do I put this? Let's write it down. So if Ft and Ft is the same, so you're gonna get m1 v1, which is the momentum of object. This one. And then you've got m2 v2, which is the momentum of this block 2. And then collision m1 v1 plus m2 is actually m2 v2. How do I write this down? So this is before. How do you put before? This is before, this is after. So this is before, this is after. So the momentum is conserved. So if the collision takes place and the object coupled, meaning the object combined. So if the object combined, you're going to get a common velocity. You're going to get m1 plus m2, and they are moving at a common velocity. Let's just put what? V3 kah? Can lah. Plus m2 v2. Okay, so there are two cases lah. Sometimes they collision happens or any sort of event happens, they do not join with each other. Sometimes collision happen or all sorts of joints happen, all sorts of collision happen or events happen. If the mass is together combined, then they will move at a common velocity. Common velocity. And this one, combined mass. Okay. Okay, so momentum is conserved. Before and after momentum is conserved. So now let's do this problem. I hope you jot down these formulas, because now we're going to be doing, we're going to clear this up. Erase all ink on the other side. Okay, we're going to erase. Let's do this one. So now we have to use equation number 2, which is m1 v1 plus m2 v2 equals m1 plus m2. It's traveling at a common velocity v3. Okay, let's draw this one to the right, this one to the left. So this is 1.5 meter per second. This is 0.75 meter per second. This is 15,000. This is 12,000. Kilo. So m1. Okay, let's write it down. 15. Velocity 1.5 plus m2 12,000. Velocity negative 0.75. So momentum is a vector. It will have direction. So you've got negative because of this one. So 15 campur 12 jadi 17,000 bukan 27,000. 27 kali dengan V3. So V3 sama dengan, let's solve this step by step. Let's solve this step by step. 15,000 kali. Yeah, again, I can really cancel this 1,000 off. 1,000 ni kalau saya boleh cancel 1,000, sebab semuanya 1,000 kan. Bahagi 1,000. So 15 kali 1.5 je lah. 15 kali 1.5. 22.5 plus 12 kali 0.75 minus 9 equals 27 V3. V3 sama dengan bahagi 27 0.75 meter per second. So if you notice, this is positive, so the cut goes to the right, kanan. Okay, so the speed, this is the combined speed of both cars after coupling. Next will be the average force between them if the coupling takes place in 0.8 second. Okay, so we've done part number 1. We've done part A. Now let's do part number B. Average force. So average force, you have to analyze either one of them. Let's say you look at A. Look at the momentum equation for A. F you don't know F dt jadi ft lah. T is 0.8 second. Mass. So you have to analyze either one of them. Don't analyze both. So the mass is 15,000. Original velocity 1.5. Final mass is still 15,000. Final velocity, it becomes 0.5. So dapatlah F sama dengan 15 kali 1.5. 22,500 minus kali 0.5. 7500 bahagi 0.8 dapat 22500 minus 7500 bahagi 0.8. Berapa? 18750 Newton. So you get yourself 18.75 kilonewton. 18.75 kilonewton positive. Correct No, this is wrong actually. It's the other way around. You see, if you look at this, look at here. This is final. This is original. So currently I'm getting a force like this. So this is positive. This doesn't make sense, right? So final is supposed to be not 1.5. It's actually 0.5. Original velocity is supposed to be 1.5. So that's just the way it is lah. Original velocity is 1.5. So this one is actually not 22.5 minus 7.5. It's actually 7,500 minus 22,500. Bahagi 0.8, you're gonna get a negative. You're gonna get a negative. Okay. The force is actually negative. So the force is actually to the left. So now it makes sense. If you hit something, you're gonna get a reaction force of a different direction lah. So this is the force. This one, I'm doing this for cut A only. You can try and do it. I'm doing this for A. You can try and do this for B. See what happens. So what is important here? I guess this formula is important. Ft minus mv minus mv naught. It Let's look at the formula again. Ft is equal to mv minus mv naught. What is important? This is important. Final. This is original. So, final velocity dia bukan kosong kan? It's not 0. It's 0.5. Let's say it becomes 0. Let's say, just try it out. Let's say it becomes 0. Kalau final jadi 0, what happens? 15,000 times 0 minus 12,000 times original velocity. How much? 1.5 divide by 0.8 F. What is F? Let's say this train hit a dead-on wall. So definitely you're going to get a negative. This one is a negative, eh? What is the value? So this one becomes 0 lah. Gone. I'm losing a decimal here. 12,000 times 1.5. 18,000 bahagi 0.8. So you get 22,500. C, 20,500. There you go. It will be significantly higher compared to this one. So yeah, your final velocity helps. If you crash and you are halted suddenly to a sudden stop, then the force will be deadly. But if you crash and you are still moving, you're fine, eh? If you look in the movies are widescreen. If you are, let's say a very bad example, let's say you've got a lorry. This is a lorry. Why lorry got so many wheels? Minus 2 wheels. Okay. So let's say the hero is standing here. So the lorry is going left. The hero wants to jump. Okay? The hero wants to jump. The lorry is going to the left berapa? Let's say he's traveling at logical speed 80 km per hour. So if the hero jumps to the right, berapa? 80 km per hour. Then the hero will be safe lah. He will just cancel out the velocity. He's just gonna drop down. Velocity equals 0. This is the thing that he is supposed to do. This is the best idea for him. So he should not. What he should not do is, dia tak patut. He shouldn't hang around here and then dangle his feet and then released. Why? He is traveling at 80 km per hour, and when he stops to a sudden stop, velocity becomes 0. He is still moving. So he's actually, when he hits the ground, he is still traveling at 80 km per hour. he will be injured badly. That's the thing. So the best thing is to jump 80 kilometer per hour and then you just roll around and round. So the longer the travel, the more gradual. Yeah, right? What are we doing here? We are increasing the time. We are increasing the impact time. Impact time. Which comes from this formula lah. Ft is equal to mv minus mv naught. The thing that you can do to improve your force, minimize your force, is mv minus mv naught over time. So this is the thing that you should do to reduce the force on the hero. What should he do? Make sure his final, the original final is not 0. Time has to be longer. If this thing is bigger, force will become lower lah, right? Same principles also people are using for erase all ink. Okay. Same principle also people are using on design of automobiles. This is a car. What is this? This is the front of the car. This is the this is a car. This is the antenna. Okay, this car is traveling this way. So actually, in front of the car, there is something called this one. There is something called this region is the crash zone, or sometimes people call it crumple zone. That means if you are met with an accident, let's say you hit the back of a lorry, not you lah, somebody else. If you hit the back of a lorry, this crumple zone will be reduced. The length of this crumple zone will be reduced. Reduced by how much? I guess all lah. It should be reduced to a very minimum. So this crumple zone is probably about 40 centimeter, probably 40 centimeter. This is the region that absorbs the kinetic energy. So you know about kinetic energy already, right? Kinetic energy. So now your kinetic energy has to be converted to something called strain energy. Strain energy. Kinetic energy converted to strain energy. If you don't remember strain energy, it can be as simple as this lah. Spring energy, half k x squared. Stiffness, displacement. Okay. So the thing that engineers do still related to this lah. Ft is equal to mv minus mv naught. So T, bring it over here. You want to reduce the force. You want to lengthen the time, meaning you want to make your crumple zone absorb a lot of those energies. So 40 cm is it's not very long lah. So if your car is traveling like 100 kilometer per hour, berapa dia punya in meter per second? 100 divided by 3.6. 27.8 lah. 27.8 meter per second. Okay. If by worst case scenario, this car which is traveling at 100 kilometer per hour or 27.8 meter per second, if for worst case scenario this car does not brake at all 100 kilometer 27.8, so impact time you can calculate already. Calculate impact time. S is equal to Vt. Did you get this? V is equal to S over T. V is velocity, S is displacement, T is time. Okay, so time is equal to S over V lah. S is meter, V is meter per second. Dapatlah S. Okay, so you can calculate lah. How much time is equal to 40 centimeter. 0.4 meter divided by 27.8 meter per second. So you're going to get how many seconds lah? 0.4 bagi 27.8. That's it lah. 0.014 0.014 second. This is how long you have lah. 14 millisecond. So 14 millisecond is huge lah. It's not huge it's very short. If you plug in here 14 millisecond and you plug in the weight, let's say the weight of the car is 1,000 kilogram. Velocity you can plug in already. Final velocity katalah 0. Oh teruk it's gonna be bad So F is equal to 0 minus 1,000 kilogram times speed 27.8 divided by 14 times 10 to the power of negative 3. You can get how many kilonewton Engineering 1985 kilonewton. Very crude calculation lah this one, so it's very big. So this is if it happens for 14 millisecond. This is making it worse lah. This is the thing. This is causing it to be huge. If you can somehow lengthen this time, you're gonna be okay lah. So you as automotive engineers maybe wanna lengthen your crumple zone, right? What do? You cannot lengthen this already, right? What do? Because behind here you have this very heavy big object. What is it called? This heavy object is called engine. An engine is very heavy and it's non-deformable. It's a huge cube. You cannot extend your crumple zone already. So what do? You design a collapsible engine mounting rack. Meaning bila crash, this engine will drop down. And what happens? Dia drop down lah, terjatuh, tergolek, engine jatuh. So this engine will be no more. So your crumple zone can increase a bit more lah. Things like that, right? So engine jatuh. Yeah, so engine jatuh is a feature. It's not something that engineers take for granted. engine jatuh is a feature, right? I think you remember few years ago, Proton Prive, engine drop on the Jalan Raya and people were laughing about it. So clueless people laughed about it lah. Engineers, they cheer because the engine drop is a feature. In order to save this guy inside this car, driving this car, you drop your engine. Okay? Habis cerita. This one you can do on your own, very easy. This one not so hard. Firing takes place in 0.03 second. You have to decide lah. M1 V1 plus M2 V2 equals M1 V1 plus M2 V2, or M1 V1 plus M2 V2 equals M1 plus M2 V3. That's the thing lah. Nak buat ke? Ada jawapan tak? Tak ada jawapan pula tu. There's no answer. No answer want to do ah. Okay lah, let's do it. I hate doing things without answer. 12,000 kilogram cannon fires 8 kilogram projectile. Okay. Muzzle velocity 500 meter per second relative to the ground. If the firing takes place in 0.03 second, determine the recoil velocity of the cannon just after firing. Recoil, dia pergi belakang. Average impulsive force on the projectile. We'll do part of it. So M1 V1 plus M2 V2 equals M1 V1 plus M2 V2. Let's take cannon as 1. The bola probably here is 2. So 1200 times velocity. Okay, there's this thing. This is B. Before. This is after. If this is before, this is after, what is this? Okay, this is incident. This is incident or peristiwa. This is what happened lah. What happened? What happened is firing lah. This is in this case firing. Previous case it was crash. Okay, so this one we have to be clear. This is the incident. Okay, M1 V1. M1 1200. Velocity before. Cannon tak bergerak kan? 0 velocity. What else? Projectile 8 kilogram, 0 velocity because nothing happens. And then you fire. Fire, kaboom. Mass of the cannon 1200. Velocity you don't know. Plus 8 kilogram, and this 8 kilogram, it fires, right? It goes very fast in front. How much? 500 meter per second lah. 500. So this is what you get lah. 0 plus 0 equals 1200V plus 8 kali 5. Berapa? 40. 4000. So you've got V sama dengan negative 4000 divided by 1200. You get negative 4000 divided by 1200. 3.33 meter per second. That is the recoil of this cannon. Yeah, right. So none of us have fired a gun except me. Good. I've fired a gun before. This is a gun. This is a gun with a trigger, and you've got a bullet. So when the bullet travels forward, you're gonna have stock hitting your elbow, hitting your chest due to recoil. So if you fire, how to say fire. So recoil. So your gun actually goes up and goes up and goes up and goes up. It becomes not accurate. So your gun will go up. So we will not shoot accurately lah. So you gotta take short bursts. Short burst in order to be accurate. Unless they can design a way that they can cancel off this recoil. Cancel off with some recoil springs. The engineer have to design properly. Okay, next. How many more have we got? A few more. Then we're done. One more, What time is it? Maybe this one. One more. Last one. Alright, let's do a last one. Two cars, A and B, have a mass of 2 megagram. Okay. And 1.5. A and B. 2000. 1500 kilo. Magnitude of VA and VB if the cars collide and stick together while moving with a common speed of 50 km per hour. Okay. VA tak tahu. VB tak tahu. Tapi they crash. Upon crashing, it was observed with a traffic light CCTV that both of them are traveling at 50 km per hour at this direction. Maybe they have a CCTV, or they are looking at tire tracks, or they are looking at tracks, kesan jalan probably. Yeah, you can do some sort of what are we doing right now? Accident investigation. JPJ Is it JPJ? No, it's traffic Traffic investigator. You want to know which car is going faster, which car is going slower. But they found out the carnage after the accident is this much lah. So what to do? You can use momentum lah. M1 V1 plus M2 V2 equals M1 plus M2 V3. What is wrong? The wrong thing is you have this one lah. You've got vectors. VA is going this way. How much? 45 degrees lah. VA. So you got VA cos 45I. VA sin 45J. This guy was going like this. So VBI, or actually negative VBI. You have to solve like that. You have to use vector. This is the vector for VA. This is the vector for VB. You gotta solve it using vector. How does the equation look like? 2000. Velocity. This one you know already, right? This one becomes 0.7071 VA I plus 0.7071 VA J. What am I doing? Correct This can be very long lah. Plus M2 berapa? 1500 negative VB I equals 2000 plus 100, so 3500. This vector is like this, 30 degrees there, so 60 degrees here lah. 60 degrees here, so 50 cos 60, 50 sin 60. Very long 50 cos 60 I, correct, plus 50 sin 60 J. Yeah, this is how you solve it. Multiply. I'm going to use a different color. Yellow, orange. This one multiply. This one also multiply, okay? This one definitely, This one also multiply and expand. And then you have to equate lah. Equate, cari I apa, J berapa. Let's try to do it Don't be lazy. Let's do this thing. 2000 kali 0.7071 1414 VAI. Senang this one. 1414 VAJ minus 1500 VBI equals, I need a bigger space or not. 3,500 50 cos 60 kali 3500 87,500 87,500i plus 50 sin 60 kali 3500. Why so big ah? Cos 60 0.5 sin 60 50 sin 60 50 sin 60 times 3500. So big ah. If need more space. Plus 1 5 1 5 5 4 J Imagine that yeah, so you can solve it already. So now look at I component. 1414 VA tolak 1500 VB equals 87,500. Next, look at J. 1414 VA equals 151554. Itu je lah. If you look at J, you have to remove J lah. Then you can equate. This is first equation. This is actually equation number 1. This is ini boleh solve We can solve this one. That is equation number 2. So VA equals bahagi 1414. Really? 107.2 kilometer per hour. So you notice I don't have to change to meter per second because equal, you can cancel out. VA sama dengan ni. Next, what you do is you gotta take this one and substitute in VB. I guess I could do that. Times 1500 negative 87,500 bagi answer. Oh no. 107.2 times 1500 plus 87,500 bagi 1414. 175. So fast lah. Do it properly Do it properly. Correct lah. Takkan dapat 175. Kau cuba check jawapan. .2 VA is, okay, let's check. 107.2 divide by 3.6 29.77 correct lah. 29.8. Plug in. I don't have a space to plug in. Where is the space for me to plug in? Up here lah. Plug in the values. So it becomes 14. Hiya, no matter lah, no wonder you're doing wrong. Bukan plug in ke VB. Mega mistake again Mega mistake. VA. Plug in lah ke VA. Oopsie. Plug in to VA. Alright, I can do this. 14 times 107.2. Minus 87500 divided by 1500. 42.72. 42.72 bahagi 3.6. This is kilometer per hour, or 11.86 meter per second. Remember, you are a traffic investigator. Siapa kereta yang laju? Kereta VA lah kan laju kan? VA was going at 107.2 km per hour in jalan kampung. VB tidak bersalah. He is travelling at 43 km per hour only in jalan kampung. So kereta A lah kena saman. Doesn't make any sense Saman 300 only. What? Insurance claim. Padahal dia ni drive very fast, right? Cannot be 300 lah. This guy 3000 saman. And pay to this guy in VB. Okay. I guess that's it 11.86. The rest is about the same lah. Momentum and impulse. This one also you can locate. Alright, so that's all for impulse and momentum. Kind of interesting. You'll be using it in more applications, more classes later on when you learn. Alright, so that's all.